The measurement performance domain addresses activities and functions associated with assessing project performance and taking appropriate actions to maintain acceptable performance. What are the desired outcomes here, Mr. Izgi?
Mr. Tekir, effective execution of this performance domain results in the many desired outcomes, such as a reliable understanding of the status of the project, actionable data to facilitate decision-making, timely and appropriate actions to keep project performance on track, achieving targets and generating business value by making informed and timely decisions based on reliable forecasts and evaluations.
Can you give us introductory information about this performance domain?
Measurement involves assessing project performance and implementing appropriate responses to maintain optimal performance. The measurement performance domain evaluates the degree to which the work done in the delivery performance domain is meeting the metrics identified in the planning performance domain. For example, performance can be measured and evaluated using baselines identified in the planning performance domain. Having timely and accurate information about project work and project performance allows the project team to learn and determine the appropriate action to take to address current or expected variances from the desired performance.
Why do we use measures?
Measures are used for multiple reasons, including evaluating performance compared to plan, tracking the utilization of resources, work completed, budget expended, etc. Demonstrating accountability, providing information to stakeholders, assessing whether project deliverables are on track to deliver planned benefits, focusing conversations about trade-offs, threats, opportunities, and options, and ensuring the project deliverables will meet customer acceptance criteria.
The value of measurement is not in the collection and dissemination of the data, but rather in the conversations about how to use the data to take appropriate action. Therefore, while much of this performance domain addresses various types of measurements that can be captured, use of measures occurs within the context of activities in other performance domains, such as project team and stakeholder discussions, coordinating project work, and so forth. Mr. Izgi, how is this performance domain related to portfolio management?
This performance domain focuses on measures for active projects. A portfolio leader may want to include measures that address the success of the project after it is completed, such as whether the project delivered the intended outcomes and benefits. Portfolio leaders may assess if the project outcome increased customer satisfaction, decreased cost per unit, or other measures that are not available until after the project has closed. Similarly, business managers may assess the project from the perspective of the value the outcome brings to the organization. Business measures might include the increase in market share, increase in profit, or decrease in cost per unit. The measurement performance domain addresses measures and metrics that are used during the project.
Okay, now we come to a new topic, which is establishing effective measures. Establishing effective measures helps to ensure the right things are measured and reported to stakeholders. Effective measures allow for tracking, evaluating, and reporting information that can communicate project status, help improve project performance, and reduce the likelihood of performance deterioration. These measures allow the project team to use information to make timely decisions and take effective actions. Can you explain to us key performance indicators, Mr. Izgi?
Key performance indicators, abbreviated as KPIs, for projects are quantifiable measures used to evaluate the success of a project. There are two types of KPIs: leading indicators and lagging indicators.
What are the leading indicators?
Leading indicators predict changes or trends in the project. If the change or trend is unfavorable, the project team evaluates the root cause of the leading indicator measurement and takes actions to reverse the trend. Used in this way, leading indicators can reduce performance risk on a project by identifying potential performance variances before they cross the tolerance threshold. Leading indicators may be quantifiable, such as the size of the project or the number of items that are in progress in the backlog. Other leading indicators are more difficult to quantify, but they provide early warning signs of potential problems. The lack of a risk management process, stakeholders who are not available or engaged, or poorly defined project success criteria are all examples of leading indicators that project performance may be at risk.
Okay, and what are the lagging indicators?
Lagging indicators measure project deliverables or events. They provide information after the fact. Lagging indicators reflect past performance or conditions. Lagging indicators are easier to measure than leading indicators. Examples include the number of deliverables completed, the schedule or cost variance, and the amount of resources consumed. Lagging indicators can also be used to find correlations between outcomes and environmental variables. For example, a lagging indicator that shows a schedule variance may show a correlation with project team member dissatisfaction. This correlation can assist the project team in addressing a root cause that may not have been obvious if the only measure was schedule status. In and of themselves, KPIs are simply measures that have no real use unless and until they are used. Discussing leading and lagging indicators and identifying areas for improvement as appropriate can have a positive impact on performance.
Let's talk about the metrics now.
Measuring takes time and effort, which could otherwise be spent on other productive work. Therefore, project teams should only measure what is relevant and should ensure that the metrics are useful. Characteristics of effective metrics or SMITE criteria include specific. Measurements are specific as to what to measure. Examples include the number of defects, the defects that have been fixed, or the average time it takes for fixing defects. Meaningful measures should be tied to the business case, baselines, or requirements. It is not efficient to measure product attributes or project performance that not lead to meeting objectives or improving performance. Achievable. The target is achievable given the people, technology, and environment. Relevant. Measures should be relevant. The information provided by the measure should provide value and allow for actionable information. Timely. Useful measurements are timely. Information that is old is not as useful as fresh information. The SMART acronym can use alternative terms. For example, some people prefer measurable instead of meaningful, agreed to instead of achievable, realistic or reasonable instead of relevant, and time-bound instead of timely. Forward-looking information, such as emerging trends, can help project teams change direction and make better decisions.
How do we know what to measure?
What is measured, the parameters, and the measurement method depend on the project objectives, the intended outcomes, and the environment in which the project takes place. Common categories of metrics include deliverable metrics, delivery, baseline performance, resources, business value, stakeholders, and forecasts. A balanced set of metrics helps to provide a holistic picture of the project, its performance, and its outcomes.
By necessity, the products, services, or results being delivered determine the useful measures.
Customary measures include information on errors or defects. This measure includes the source of defects, number of defects identified, and number of defects resolved. Measures of performance. Measures of performance characterize physical or functional attributes relating to the system operation. Examples include size, weight, capacity, accuracy, reliability, efficiency, and similar performance measures. Technical performance measures. Quantifiable measures of technical performance are used to ensure system components meet technical requirements. They provide insights into progress in achieving the technical solution.
Delivery measurements are associated with work in progress. What are the main measures used in projects using adaptive approach?
The first one is the work in progress. This measure indicates the number of work items that are being worked on at any given time. It is used to help the project team limit the number of items in progress to a manageable size. The next one is the lead time. This measure indicates the amount of elapsed time from a story or chunk of work entering the backlog to the end of the iteration or release. Lower lead time indicates a more effective process and a more productive project team. The next one is the cycle time. Related to lead time, cycle time indicates the amount of time it takes the project team to complete a task. Shorter times indicate a more productive project team. A consistent time helps predict the possible rate of work in the future. The next one is the queue size. This measure tracks the number of items in a queue. This metric can be compared to the work in progress limit. Little's law states that queue size is proportional to both the rate of arrival in the queue and rate of completion of items from the queue. One can gain insights into completion times by measuring work in progress and developing forecast for future work completion. The next one is the batch size. Batch size measures the estimated amount of work, level of effort, story points, etc., that is expected to be completed in an iteration. The next one is process efficiency. Process efficiency is a ratio used in lean systems to optimize the flow of work. This measure calculates the ratio between value-adding time and non-value-adding activities. Tasks that are waiting increase the non-value-adding time. Tasks that are in development or in verification represent value-adding time. Higher ratios indicate a more efficient process.